So good morning. This is Dr. David A. Padgett. This is Weather and Climate, Geography 3500, Spring Semester 2021. Today is Tuesday, February the 16th. And so today, I'm going to share my screen. We have a few things to cover today that are posted here on the schedule. Let me make sure that you all can see that. Okay, looks like everything's there. So today is, again, February the 16th. And so we're at week 4. And so here is the week 4 schedule. And so as you can see, we have a few things to discuss this week. And so the first thing is the article review. I'm going to introduce you to the article reviews. I'll talk about the plan is to do a daily weather report. I usually do a daily weather report in here. I think I'm going to go ahead and do that. And then we're going to briefly explore the your term paper. Want us to get started on that. And then I'm going to lecture over the difference between weather and climate, and then you'll get your 4th assignment. So again, that's what we're going to do today. I'm going to pause the recording for one. Okay, so I just made a couple of highlights. I just wanted to highlight the article review assignments in red so that it would draw your attention. Notice that in the schedule, you have article review 1 due here. And so there's the drop box. And so let me go back to view as student here. Article review 1, drop box is here for you to submit. So the article reviews are discussed in the course syllabus, which is here. So each week, beginning this week, you must complete an article review. And I'm just going to talk about what that is right now. And so there's a specific format for the article reviews. It's explained here in the syllabus. And so article reviews on weather and climate. And so each week you'll turn in an article review. Each week you will turn in 1 article. Okay, don't turn in 10. It's not 10 per week. You're not in graduate school yet. No, this is just for undergrad. So you must search academic journals, popular magazines, newspapers, internet, or other media sources discussing the weather and climate issues. Okay, it can't just be about anything. So you should have an easy time this week because if you live basically anywhere in the southeast, we are dealing with I don't want to say unprecedented, but we're dealing with a storm and extreme cold event that has not visited the southern part of the country in at least a decade or maybe longer. Some of these very cold temperatures, single digits in parts of Texas and Louisiana, and that's real temperature. That's not just the wind chill temperature. So should be easy to find an article about weather and climate. You must cite the article, and if you just follow these steps, it should be pretty easy. So just put a citation. You can use any style here, MLA style, so on and so forth. I've also included in the course content if you'll notice under course content, there is an MLA style guide here. And so if there's any confusion about how to cite any kind of article, most of you will find articles online. And so there are ways to cite online newspaper articles, how to cite online journal articles. If you just find a website, how to cite that. So you include a citation. Then somewhere on the page, the article number, the first one will be article number 1, due next Tuesday, the date, your name, and your major. You'll write a 250, 350 word essay thoroughly summarizing the article's contents. Must be written in first person. And so first person voice. I read an article in the American Meteorological Society entitled blah, 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 blah. So must be first person voice. In your essay, describe at least 3 things you learned while reading the article. Include 3 to 5 keywords. A keyword is a word or phrase that speaks to the core theme of the article. And so if you wrote an article about, if you found an article about this ice storm that struck Nashville, Tennessee, one of your keywords is obviously going to be location, Nashville, Tennessee. Another keyword might be, in this case, it's sleet. I don't think we got freezing rain. There is a difference between sleet and freezing rain. We'll talk about the various forms of frozen precipitation later on. And now, if you found an article that is in a printed source, if you have, for whatever reason, if you actually read a print newspaper and you found a really good article in that newspaper, if only if it's hard copy, take a clear photograph of it, and then of the title page, include the title of the article, and then just upload that as an image to your Dropbox along with your essay. And so that is what you'll start turning in every week. So question, Dr. Padgett, does that mean we have 2 assignments this week? Yes, that's exactly what that means. You have 2 assignments this week. So you'll have an article review due every week. And also this week, you'll do the other assignment that is, I'll describe later on today. And so let's move back into the today's schedule for week 4. Okay, so I'm going to pause recording for just a minute. Okay, now we'll get into today's lecture, which is what is weather, what is climate? And so the name of this course is Weather and Climate, which implies that those are 2 different things. They're similar, but they're different. And so at content, you'll notice I have a weather versus climate characteristics table. Okay, and so here we have, download this so that it looks a little bit better on the screen. And so this is, organize this in a graph so that we can get a better visual representation of the differences between weather and climate. So weather and climate, what are the differences, so on and so forth. First, in terms of time, when we speak of weather and climate, what's similar is that we're talking about atmospheric conditions. And so the atmospheric conditions include temperature, precipitation, insolation is incoming solar radiation, wind, pressure, and other variables. So those are the variables here that are in common in terms of weather and climate: temperature, precipitation, insolation, wind, and pressure. Temperature and precipitation are the two main elements of weather, and especially climate. When we start to look at climate, we will really start to take a deep dive into historical data and so on and so forth. Now, when we look at differences in terms of geography, when we say weather, we're talking about atmospheric conditions, usually in a localized area. Okay, usually within a localized area. With climate, we'll look at climate regions, larger areas, continents, nations, and so on and so forth. But we also can look at climate in local areas too. In terms of time, we speak of weather, we're usually asking questions about atmospheric conditions with shorter periods of time. What's the temperature going to be like today? How much precipitation are we going to get today? Is it going to be sunny today? Are we going to have, what percentage cloud cover are we going to have today? And we've been through a little bit of this with your first couple of assignments. What's the wind direction going to be today? For wind speed, the instrument that's used to measure wind speed is an anemometer. A wind vane is used to measure wind direction. What's the barometric pressure in millibars going to be today? That's weather. In terms of climate, when we speak about periods of time, it could be months, years. What are the average temperatures, precipitation, etc., that we see over longer periods of time? Months, years, decades, in some cases, centuries. There's even a field called paleoclimatology, which is the combination between climatology and geology, where in some cases ice cores are drilled at the poles so that we can see what the climate was like millions of years ago in some cases, because presumably when those gases were trapped in the ice, they were trapped just as they were however many millions of years ago that was. So that's how we can determine how much carbon dioxide was in the atmosphere, centuries ago or thousands of years ago, and so on and so forth. And then in terms of climate, we're looking at monthly average temperatures, precipitation, monthly or annual averages, and so on and so forth. In terms of insolation, average number of sunny days per year, and so on and so forth. And so that's how weather and climate are different. In terms of how these are symbolized on maps, we have isotherms, which connect points of equal temperature, and isohyets, which connect points of equal precipitation. So let's move away from here and look at some of the ways that we will measure or examine weather versus climate in the coming weeks. We start to actually examine these things. Okay, so we spoke of climate. And so here is an example of a map of climate globally. So we're looking at, here's the world and this is in degrees Celsius. Notice that in and around the equator, the average temperatures are higher on average. As we move towards the poles, they tend to be lower, as you can see. So this is a map of climate. The source of this map was probably taken with data over a, well, actually it says here, from January to December 1968 to 1996. So this is almost a 30-year record of temperature on average that we're looking at graphically displayed here. Now, on the other hand, if we are looking at weather, then that would take us to looking at the, say, daily weather map. And so we may as well segue right into our data stream map and look at today's weather map. Okay, so this is February the 16th, and that's today. And so we're going to do this every day, is take a look at weather. So the last map I just showed you was a climate map. Didn't show you precipitation, but just temperature over a 30-year period. That was a display, that was a visual display of climate. Now here's a visual display of weather. So this is, of course, today. And again, when we speak of weather, we're mostly interested in what is happening locally. So what you're going to have to do, you will have a midterm exam in here during midterm week. One of the things that you'll have to do is interpret a weather map. So that's what we're going to do pretty much every time we meet. Okay, so first of all, let's look at this map, orient ourselves here. And also, this is probably one of the tools that you should use to complete this week's assignment, is this weather map. You're absolutely going to have to use it. Okay, so let's look at some of the map symbols. And let's take Nashville, Tennessee. So here's Nashville, Tennessee. Okay. And if you notice, there's this map symbol, this line symbol with these teeth, it looks like. That represents a cold front. Okay, so if I was to ask you, for example, what type of frontal system is affecting Nashville, Tennessee, then the arrows point in the direction of that the air is moving, that this cold air is moving from north to south. And notice how far south these cold fronts are. And so what is happening right now is we have generally moist air coming from the Gulf Coast region, and it is mixing with this very cold air. So you have moist air full of moisture collides with cooler air, and of course you get freezing rain, sleet, snow, and extremely low temperatures. So I'm going to back out of this for a moment, just so that we can get a better idea of how to interpret a weather map. So that you will be prepared to complete the upcoming week's assignment. And so let's look at these weather map symbols, okay? So look at this very carefully. So what this point symbol represents is a weather station, okay? So it's most likely a National Weather Service weather station. So when you did that outdoor data collection assignment, you at one point looked up your local National Weather Service or official weather station. So that's what this point symbol represents here. Location of weather station, okay? Now, notice that this dot is completely filled in. That means we have 100% cloud cover. If it was half filled in, it will be 50% cloud cover on a particular day. Now over here, now a lot of these symbols we're not going to see on most weather maps. A lot of them we are. The temperature is going to be to the upper left-hand side of the circle. The dew point temperature is going to be on the lower left-hand side. The dew point temperature is the temperature at which condensation takes place. Condensation is when water vapor converts into a liquid. And so that would, of course, be when we start to see clouds. Clouds are not comprised of water vapor. Clouds are either made of ice or water droplets. Water vapor is invisible to the naked eye. When we see an air mass or air within an air mass go from having its water in vapor form convert to liquid form, then we would say condensation is taking place. So clearly, if you notice by this diagram, if the temperature, the ambient temperature is 31 degrees Fahrenheit and the dew point temperature is 30 degrees Fahrenheit, more than likely we're going to see some precipitation, assuming that this temperature falls, let's say at night or if something else happens. Another important thing is the wind direction. So we have, wind direction, in this case, coming out of the southwest, and you'll see that on the map. And so, these little tick marks are wind speed. And so here's, and this is in knots. 1 knot equals about 2 miles. Excuse me, 1 knot equals about, and so it's measured in knots, not or close to kilometer per hour, so on and so forth. And you can convert that to miles per hour easily. And then types of clouds. Remember when we did the cloud observation? Here's high clouds, middle clouds. Again, most of this is, when we switch back to the weather map, we're not going to see a lot of these things on the map. Barometric pressure will be on there. And so this is in millibars. And what you see here is a truncation of the barometric pressure reading. So in most cases, normal barometric pressure is around 1,000 and some millibars. Okay. So in order to, I guess, simplify things, the leading 1 and 0 is left off. So this is actually 1,024.7 millibars. That's what that is. So we leave off the leading 1 and 0, 1,024.7 millibars. That's how you would read that. Okay, so let's go back to the weather map for today. As a matter of fact, I'm going to download it just so that, let's see, I'll share this with you just so that you can have it. So this is February, let's say Feb 16, 2021 weather map. I'll just save that for later. Okay, so let's look at what's going on here. So again, let's focus on Nashville. It's going to be kind of hard. Let me see if I can zoom in. That's much better. Okay, so here we have Nashville. And again, right now, it's 12 degrees Fahrenheit in Nashville. and the dew point temperature is 3 degrees Fahrenheit. The barometric pressure, notice it says 225 there, so it's 1,022.5 millibars. There, the wind direction, the wind is blowing almost, I'm not too much concerned about wind speed, you can get an idea, but it's coming out of the west, almost due west. See that tick mark that's flowing, and we have 100% cloud cover. Okay. Now, not a whole lot of warm fronts happening here. We do have, interestingly enough, here we have a stationary front. Okay, so let's go back to some of the map symbols. So again, a cold front is represented by those teeth marks. A warm front is represented by the suns. An occluded front is when there's more than one air mass in one area. We'll talk about that later. And then a stationary front is just that, it's stationary. So what I'm going to ask you to do from time to time in here is to predict the weather maybe 3 days out based upon what we see here. So if you notice that we have the stationary front, so there's a cold air mass here indicated by high pressure across the Great Plains. So that high pressure is indicative of a place where air is sinking, which makes sense because we have this very cold air mass that's affecting us right now. Cold air is very dense, so it sinks, resulting in high pressure across this region. Secondly, it isn't going anywhere. So you notice we have a stationary front. So there is a, I guess, and I'm going to put this in quotes, warm front, because even behind this warm front, the temperatures are 28 degrees Fahrenheit. That's probably Albuquerque, New Mexico. Here at El Paso, Texas, it's 29 degrees Fahrenheit. That's really chilly. Well, maybe not for Albuquerque, but for El Paso, 29 degrees Fahrenheit is very chilly. But if you look on the other side of this front, then we get into single digits at Amarillo, Texas. I think this is Dallas, 6 degrees Fahrenheit. 15 degrees Fahrenheit, that's probably San Antonio, Texas. Looks like can't see anything, the weather station for Houston, which is interesting. But we have Lafayette, Louisiana here, 20 degrees Fahrenheit. And so this, now one of the characteristics of high pressure, and this is interesting, normally under high pressure, we'd have very clear skies because we have stable conditions. But notice here we have a lot of cloud cover. We do have they do have snow symbols here at Lexington, Kentucky, and Indianapolis, Indiana. So there's a few extra symbols there I wouldn't expect to see under normal circumstances. But we can see that this, that what we would expect at Nashville, Tennessee, given these conditions, is for these cold temperatures to persist, because this cold front, well, one good thing, I guess, about cold fronts is that because they're more dense, they move faster than warm fronts. So I can't say from looking at this map for today if I'm 100% sure if these cold temperatures will persist. I would say at least over the next 24 hours. If we look to the west, notice all these If we look at Atlanta, the winds coming out of the west. If we look at Birmingham, Alabama, the winds coming out of the northwest, and so on and so forth. So this air mass is clearly moving in the southwestward direction. The question is, how fast is it moving? How many days should we expect to see these conditions persist? And so what you should do when you start to work on this week's assignment, let's look at these maps, and then you can go to the national, well, I don't have to click there. We can go right to content, and we should have online weather resources. And of course, your National Weather Service site is here. So under online weather resources, you have lots of sources. AccuWeather, but let's look at the National Weather Service, and I'm going to type in 37209. It's Nashville's, so it's TSU zip code. And let's look at the 5-day forecast. So yes, today high is 22 degrees Fahrenheit. Tonight down to 13 degrees Fahrenheit. Tomorrow, a little bit of improvement, but looks like another system is coming in. And so that's interesting. It says Wednesday night, snow showers and sleet, then turning to rain, then sleet, then snow, and then more freezing rain. 90% chance of that happening. Okay, so let's go back to our weather map and see what might be the source of that. So I can't specifically see what might be coming according to this weather map, but obviously it is predicted that something else is going to follow this cold front and bring more snow, ice, sleet, etc., into our region. So what I'm doing here is just meticulously analyzing weather conditions for Nashville, Tennessee over the next several days. And so I should probably segue back into this week's assignment now that you can kind of get the gist of what you were asked to do this week. And so let's go to the back to our week 4 schedule again, and the assignment. Okay, so assignment 4, hometown weather and climate presentation assignment. Each student must produce a detailed 10 to 12 slide PowerPoint presentation describing in detail the weather and climate of their hometown cities. So it must include anecdotal and qualitative data. So what does that mean? By anecdotal, feel free to speak in first person about what you happen to be experiencing this coming week. So if it was me, I would say I have been iced in to my home for the last 2 days, probably not going anywhere tomorrow either. The roads are covered with ice in Nashville where I live, and I'm just very fortunate that I was proactive and stocked up my refrigerator and other things with food. The only thing that I did not do was get firewood. Didn't do that. Didn't get any firewood. And so let me try something here very quickly. gonna pause the recording for just a second. Okay, so here's an image of what it looks like off of my back deck. Lots of snow. And again, not freezing rain. There might have been some freezing rain mixed in, but mostly sleet. So sleet is when the water falls out of the sky in little ice balls. So it's frozen on the way down. Freezing rain is when water falls as a liquid, and then it freezes when it gets to the surface on your car, on a tree, on the ground, in the street. So obviously, freezing rain is a much more annoying because it's like your car is encased in ice, and it's very dangerous because it looks like the road is just wet, and it falls in liquid form. So you could have a false sense of security. Oh, it's just raining. And then you get in your car and hit that, what they call black ice. And it can be a very dangerous situation, as you probably saw with some of the pileups and crashes. So here's another view out front. And so in Nashville, we're just not prepared for these kinds of conditions. So there's not going to be a snow plow coming down here. There's not going to be an assault truck. Just have to wait for Mother Nature to take care of that. So when you develop your PowerPoint presentation, just 10 to 12 slides, and yes, we will, how we're going to figure out how to do these presentations asynchronously. But again, that's an example of anecdotal and qualitative data. Photographs, just your own first person viewpoint, but you must also include maps. So I just showed you how to get the weather map for the week from the data stream site. So you can get a weather map of each day included in your presentation. You can take a screenshot of the 5-day forecast and just describe essentially what is happening in your hometown this week in terms of weather. Well, what about climate? Well, that's going to take some different approach. And so when we start to look at climate, again, we're looking at some different, much more long-term descriptions of atmospheric conditions. And so we have, for example, here's a map of the average sunny days per year in the United States. So notice that this blue color area symbol represents a region that has little or low average sunny days per year, as opposed to here, the Southwest, parts of Florida. Florida, of course, is called the Sunshine State, have a greater percentage of sunny days per year on average from, again, about a 20-year period from 1990 to 2011 in this case. Excuse me. Here we have Los Angeles, California. You may or may not know that the motion picture industry, Hollywood, film, is located in Southern California because of its climate, because the less time it takes to shoot a movie, the less it costs. And so if you're guaranteed optimal conditions of sunny skies, then obviously it will take it will be more cost effective to film in areas where it's sunny. Um, and so that's historically why the motion picture industry is located in Southern California, because of the climate. Now, of course, technology has changed things a little bit, and so we see places like Georgia and Louisiana moving, uh, increasing in motion picture and film development. But historically, it was Southern California because of the climate. Conversely, we can see that there are places like Seattle and up around the Great Lakes, uh, less sunny days per year. Now, those areas are associated with the condition called SADS, seasonal affective disorder syndrome. So there are people who are, in some cases, extremely negatively affected by lack of exposure to sunlight, and they can actually fall into depression that has to be treated, either by a medical professional or a psychological professional. And so that's called seasonal affective disorder syndrome. And so people who live in those areas might suffer from that. But this is a map clearly of climate. Average sunlight over a 20-year period, as opposed to weather, where we ask, what's the percent cloud cover today, or this week? Uh, so that is, so when we look at, now we also have an interactive Kerpin climate map that you can use. Okay, so the Kerpin was a German climatologist, and who created a quantitative method for describing climate graphically, uh, using an alphabetic, I guess a combined alphabetic and color coded system. So if you see on this map, we have the several different types of climate represented by different colors and letters. Notice it's A, B, C, D, E, and E, right? So A climates are tropical climates, um, which are usually confined to the tropical region of the world, but in North America, well, we're looking here specifically at the United States, and I apologize for all the um, ad garbage that's in here, but in the southernmost tip of Florida is where we really only see tropical climates in the contiguous United States, and of course in Hawaii. Next, we have B climates. B climates are dry climates. So you can see those are dry climates. That's B. There are different categories. So we have BW. Now the W is our WBW climates are desert climates. Deserts are places that receive less than 10 inches of precipitation per year. So deserts are defined by precipitation, not temperature. So notice it says BWH, hot desert, BWK, cold desert. A lot of us might say cold desert. Yes, there are areas that are, we can look at North America and notice that there are places um, in Oregon and in Washington State that are, I guess we would call them cold deserts. I mean, these places are dry. They're on the leeward side of the Sierra Nevada mountain range, and they tend to be dry, but they're not hot. When we get in the hot deserts, when we get south into southern Nevada, Las Vegas, Phoenix, Arizona, so on and so forth. But you notice that here is Utah, southern Utah, and other these places are deserts, but they're not hot. Uh, relative to cold desert. Now I really haven't had time to get to know everybody in here, but from what I do know, I think most of the students in this class, with the exception of Theodora, are from these sea climate regions, and so this is so Theodora is going to have to use a different climate map. We'll probably have to talk about that on Thursday. But these sea climates, now there are two types of sea climates. Notice there's a hot summer Mediterranean climate, warm summer Mediterranean climate, and then there are several types of sea climates here. Now, the sea climate that we are most familiar with here in the southeastern United States is the CF, humid subtropical climate, here, here, here. And so if you zoom in on your hometown, you can pretty much get what type of climate is dominant in your area, humid subtropical, and so on and so forth. Yeah, most of us are here. Now, some of us may be in this Midwestern region. And so we either have humid continental mild summer, and so that gets us into these D climates, or we have humid continental hot summer. So there are parts of the Midwest and Great Lakes region that are D climates, but then there are differences within the D climates. And notice that there are some D climates that just are not really found. Well, a little bit here. Humid continental mild summer with dry winters. So that the various designations you can find in this table. So here are the D climates that we find in these areas here. So as you complete your assignment, you should find your hometown and describe the climate character, the Kerpin climate region specifically, and perhaps some other climate characteristics that we'll get into later, perhaps. And so you also have air masses. And again, we're focusing upon North America. Theodora will have to talk. But there are various air masses that affect our climate here in North America. And so if you notice, we have the maritime tropical. These are air masses that come off of the oceans, obviously. Then we have maritime polar. Maritime tropical climates are warm and moist. So we usually feel these mostly in the summer months when it's really hot, humid, or if you travel to Florida or Louisiana or Texas, the coastal region, the Gulf Coast region, you can really feel the humidity. And even along the East Coast region, this air mass during the summer can create some really humid conditions. Now, right now, we're being affected by this continental Arctic air mass, which is bitterly cold, very cold and dry, even colder than the continental polar air mass. So when these air masses move around, like for example, a cold front is usually when we see these cold air masses move into the southern part of the country, or anywhere really. But if we're speaking in terms of the Southeast, where most of us are, even in the Midwest, that's when we really feel these cold air masses, like right now. It's time, what's going on now. The West Coast is influenced largely by this maritime polar air mass, and so that's why we see places like Seattle um, being very cloudy and relatively cool. San Francisco, California, Northern California is very different in terms of climate from Southern California because of these different air masses. Notice Southern California is influenced either by the continental tropic air mass or in some cases the maritime tropic air mass. But Southern California, Los Angeles, San Diego, it's not a desert, but it's a sea climate that is relatively dry, as you can see from, you know, those are the other types of sea climates that we see on the West Coast. These warm summer Mediterranean climates, which are indicative of well, sometimes they're called dry summer Mediterranean climates, but what happens is it's just that there's a relatively dry summer. So in, say, Sacramento, California, it might rain, there might not be any rain between May and September, or barely any rain between May and September. And then, of course, ample amounts of rain the rest of the year. But in those summer months, very dry normally in places like Sacramento, California, and this Central Valley region of California. You can see that here with they call it a cold desert climate there in Central California, and then cold semi-arid climate, and then ranging into hot summer. So California has a really interesting mixture of climate regions. Then we have this purple area, humid continental climates. That climate is there because of the mountain range. But for the most part, I think for our class, we are going to be focusing upon the southeastern and midwestern U.S., except for Theodore. We also have an isohyets map. And so isohyets connect points of equal precipitation. And so that's a global map. So in completing this assignment, and so of course the assignment here, if you go to the Dropbox, go back to student view. Oh, here it is, hometown city weather PowerPoint. Here are the instructions here again. And so here's some weather apps you can use for weather. And of course, I have some places that you can get climate data. We'll get into more in depth about that on Thursday. Also, do not forget that this week you also have your first article review is due, and the instructions for the article reviews are, of course, in the syllabus. So I'm going to conclude today's lecture. And so thank you very much. I'm going to stop the recording.